In Episode 1, we touched upon rotary shafts and drive shafts. Now we will dive deeper into the differences between the two and application examples. If you need a refresher on any of the past shaft videos, they are all posted on our page for your review. Rotary and drive shafts are similar in shape to linear shafts, except they are designed to transmit torque and withstand torsional forces. The most popular use of these shafts is in power transmission, more specifically with timing pulleys and belts. The shafts are mounted onto the pulley in a variety of ways, such as a keyway or set screw. For the keyway design, the rotary shaft must be designed with a keyway slot to match that of the pulleys. For the set screw design, the rotary shaft will have a set screw flat so that the screw from the pulley can tighten onto it. These styles apply to both rotary and drive shafts. But what's the difference between rotary and drive shafts? Let's take a look. The biggest difference between the two are the tolerances. Rotary shafts have lower tolerance standards, whereas drive shafts are high-precision machined with higher tolerance standards. Here is a chart showing the circularity tolerances of rotary and drive shafts. The drive shaft tolerances are shown in parentheses. As you can see, the drive shaft numbers are smaller than the rotary. This circularity tolerance is important as it relates to the shafts rotating accurately without causing unnecessary vibration. Since drive shafts have a higher tolerance, these shafts are recommended for use in applications with high speed, and rotary shafts for moderate speed applications. Drive shafts have a tighter length tolerance than rotary shafts. This is because drive shafts can be used for direct mounting, where the length tolerance is important. Here are the tolerances of rotary shaft lengths, showing that tolerances are different depending on the length range. Comparing to drive shafts, they have a tolerance of plus or minus 0.2 millimeters at any length. There are many ways rotary shafts can be applied to applications. Here are a few examples highlighted from the MISUMI in-CAD library. In this application, the rotary shafts are used to transmit the torque generated from the motor to the pulleys they are mounted to. The shafts then move the machine's arm to move the rods. Here is an application where a rotary bearing is used on the rotary shaft. The shaft is supported on one side via a support and bearing. It transfers the motor's power to the winding drum, which then lifts the workpiece block. This rotary shaft application utilizes the snap ring alteration at each end of the shaft. The shaft is used in a roller to press a rubber workpiece into the concave portion of the other workpiece. The load to press the rubber is adjusted via the spring and bolt. MISUMI rotary and drive shafts can be configured with a variety of alterations, including threaded, tapped, D-cut, hex hole, wrench flats, stepped, and hollow. These alterations can be configured to lengths of up to 0.1 millimeter increments and in combinations to fit your application needs. This concludes the series on shafts. Thank you for tuning in, and be sure to check out our other videos for more information on MISUMI. Subscribe to our channel to stay up to date.